I'm Zachary, and this is Lab 3 Circuits. For part 1, we made this circuit with two 1.5 volt batteries with 2 ammeters on each side of the resistors, a 100 ohm resistor and a 47 ohm resistor. Um, the ammeters read 0.02 amps on each side. If I flipped one around, it became negative 0.02 amps. Part 2, I replaced one of the ammeters with a voltmeter with the same connection points, and the voltmeter read 0 volts because there was no potential difference from this point to this point. But in reality, there would be a slight voltage because in reality, wires have a slight amount of resistance. But in this ideal scenario, they had no resistance, so the volts was 0. And the voltmeter isn't across a resistor, so there was no volts. Part 3, voltage at different parts of the circuit. Over the whole circuit, it was 3 volts, kind of just the sum of the battery voltage. Across the 100 ohm resistor, here it was 2.04 volts, and across the 47 ohm resistor, it was 0.96 volts. For part 5, the sum of the 3 volts is 3, or the sum of the 3 voltages, or the 2 voltages, is 3 volts. 2.04 plus 0.96 is equal to 3. Theoretically, it should be 3 since this is a simulation. It is perfect. In reality, wires have resistance, and they lose energy to heat, so the voltage would not be a perfect sum of 3. It would be less than the ideal value. This is the approximate thing, voltage over time. In reality, this decrease would be less than this decrease. That was just a fault of my drawing. So yeah. Part 8 out of 10, the 8 through 10, when adding the voltmeter to the circuit, it is added in parallel so it doesn't alter the current. When connecting the voltmeter, the ammeter reading stays the same, and the reading of the first ammeter increases to 0.06 because it bypasses the resistor, because it takes the path of least resistance. For part 11, the 47 ohm resistor was about 47 ohms, 0.96 volts divided by 0.02 amps is equal to 48. 100 ohm resistor, 100 ohms, 2.04 divided by 0.02 is 102. The wire in this sim, wires have no resistance, but in reality, it would be slight. There would be slight resistance in it. In the ammeter, also has no resistance, but in reality, there would be slight resistance. For the 3 RC circuit, part 1 through 3, we were not able to do this in lab, and because of that, we had to use the PhET simulation, but the PhET simulation did not have a good capacitor circuit lab that we could alter or customize. This was the most customization we could do. We couldn't change the resistance of the light bulb or connect it all together at the same time. So we could only really do part 3. The bulb starts very bright here, and then as it dims as the capacitor loses charge. This is at the very start before I connected it. Then it goes here, and then it eventually, the capacitor loses charge, and this becomes dim. What if you charge the capacitor with no resistance in the circuit? How quickly would your ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain, use an ammeter. This last part we can't do because we did not have the equipment in lab. In reality, theoretically, it would instantly charge because there's no resistance in the wires, and no resistance at all would mean it instantly charges. But in reality, wires have resistance, the batteries have resistance, and that would slow the charging down. And that's everything. Thank you.